Section 15.5, the normal distribution and estimating probabilities. So back in section 13.4, we looked at histograms, and when we were doing that, we started talking about the shapes of distributions, and one of those shapes was referred to as the bell shape. Well, the more official and statistical name for that shape is called the normal distribution, so we're going to look at a definition of that here. The normal distribution is a symmetric bell-shaped distribution with a single peak. Its peak corresponds to the mean, median, and the mode of the distribution. So we mentioned back then that if we have a symmetric curve with a single peak, that the mean, the median, and the mode are all in the same place, and that does apply to this distribution. A key thing in looking at normal distributions for us will be to use the standard deviation. The standard deviation of a normal distribution is the measure of how much variation there is in the distribution, and the symbol for the standard deviation is the Greek letter sigma. Now you might remember back in section 14.2 we talked about standard deviation and we used the symbol S there. So it turns out that S stands for sample standard deviation and this Greek letter sigma stands for population standard deviation. The difference between the sample and population will be discussed much more in your stat class. So for now, just kind of think of them as basically the same thing, but you will notice in this section we'll be using this Greek letter sigma when we talk about the standard deviation. So just a reminder, what is it that the standard deviation tells us? It says that the larger the standard deviation, the more variation there is. So that was one of the things we talked about when we were discussing standard deviation. It measures spread, so a bigger number means more variation. And the smaller the standard deviation, the less variation there is. All right, and also in section 14.2, we discussed the empirical rule a little bit, and now we're going to look at that specifically for normal distributions. So the empirical rule is also known as the 68, 95, 99.7 rule for the normal distribution, and that's the way they're referring to it here. But that is commonly known as the empirical rule, so I'll write that name on the side as well. So we use those interchangeably, the empirical rule and the 68, 95, 99.7 rule. And what this rule says is that for a normal distribution, about 68%, or just a little over 2/3 of the data, fall within one standard deviation of the mean. About 95% of the data fall within two standard deviations of the mean. And about 99.7% of the data fall within three standard deviations of the mean. And they have a picture of that here for a normal curve. If you have your mean in the center and you add one standard deviation to that to the right and to the left, then that's creating this set of boundaries right here. And they're saying if you look at how much data is in that section, it'll always be about 68% of your data for a normal distribution. And then if you go out a little further, twice as far in fact, and you go two standard deviations to the right and two standard deviations to the left, and you say, okay, how much of my data fits in this range? You should find that that typically ends up being about 95% of the data for a normal distribution. And then if you went out a little bit further still, three standard deviations to the right and three standard deviations to the left, then you would get almost all of your data. This 99.7% is what you would expect. And there's only 100% of the data overall, right? So by the time you go out three standard deviations in each direction, you're going to pick up almost everything. So there's a little bit that's left on the outsides. I guess if you look at 100 minus this, there's 0.3% left for the outsides, but not very much at all. All right, so I just mentioned a percentage that's not actually part of the empirical rule, so let's make a note of that here. The total area under the normal curve is 100%, or that would be 1 if we were measuring it in decimal form. And it turns out we're going to use this number a lot more than we use the 99.7 in the 68, 95, 99.7 rule. As we do examples, as we do homework, you'll just see that we don't use the three standard deviation number very often, but we will have questions that ask about area out forever to the right or forever to the left. And this curve doesn't stop at plus and minus three standard deviations. It does go forever to the right and forever to the left. Like we mentioned, there's not much area past there, but there's some. So to get those problems correct, you're going to have to use this idea that the total area under a curve is 100%. So for the purposes of the homework and examples we're going to do and our quizzes and the final, you should really think of this almost as the 68%, 95%, 100% rule. and you'll see us thinking mostly about going out 1, 2 standard deviations or forever. If they happen to mention 3, you'd use the 99.7, but you're not going to use that very often. All right, let's go ahead and take a look at a couple examples. Okay, let's go ahead and look at an example of how the empirical rule can help us answer questions about a normal distribution. The resting heart rates for a sample of individuals are normally distributed with a mean of 70 and a standard deviation of 15. Use the 68, 95, 99.7 rule to find the percentage of heart rates in each of the following categories. And the first category they want us to do is less than 55. So here's my strategy on this. The first one is I want to visualize it. So I'm going to draw in a bell-shaped curve. So I'll draw in my axis, draw in a bell-shaped curve, and near the peak, if I drop down, that's supposed to be the mean. And it says in the problem that we have a mean of 70 for this distribution. So I'm going to put 70 right there. And then the next thing I would do to start thinking about the 68, 95, 99.7 rule, or the empirical rule, is I would want to count using the standard deviation of 15 in each direction till I got 3 standard deviations on each side, and that would be about the flattening out spot. So I want to kind of think about making 3 tick marks to get to the flat spot. 1, 2, 3. And that should be about 3 standard deviations. So I want to add 15 to this, which would be 85. And then add 15 again, which would be 100. And then add 15 again, which would be 115. And that would represent 1 standard deviation to the right, 2 standard deviations to the right, and 3 standard deviations to the right of the mean. If you want to move in the other direction, then you'd want to subtract 15. But we still want that same idea that it's going to be 1, 2, 3 tick marks, and then we're at the flattening out spot. So this time I'm subtracting 15. So 70 minus 15 would be 55. And then subtract 15 from that, we would be at 40. That would be 2 standard deviations to the left. Subtract 15 again, and we'd be at 25, and that would be 3 standard deviations to the left. And now that I've got that labeled, I want to think about their question. And what are they asking us? What percentage of the heart rates are less than 55? So I'm going to draw a line at 55, and then I'm going to shade the part of this curve that is less than 55. And I can try and use the empirical rule to think about what that would be. So here's how I'm going to do that. First of all, I want to think about this 55, how many standard deviations away from the mean it is it? And because the way we counted this, we should be able to just tell that was 1 standard deviation to the left. So what you want to do to use the empirical rule is if your boundary is 1 standard deviation away, then you probably want to go ahead and draw in the other mirror image boundary that's also 1 standard deviation away. And you can see I kind of have a lack of symmetry here. So it's very rare you're going to hand draw one of these curves perfect. But this area right here, in between 1 standard deviation to the left and 1 standard deviation to the right, if we look at the empirical rule, if you go 1 standard deviation right and 1 left, you're supposed to have 68% of your data right there. So I think that in the middle, I should have 68%. Now I don't want the middle, I want this left side, but by figuring out the middle it gets me started. If we think about the middle, we could then say, well, how much is left over? And we could say I can take 100%, which is the total amount of data, and subtract the 68 that's in the middle, and that would leave 32. But where's the 32? And the answer is it's not in the middle. But it's not necessarily all over here, and in fact, because of the symmetry of the curve, this 32 should be split up among the 2 outside pieces. So my next calculation would be to take that 32, cut that in half, and that would be 16, and that should be the percent on each side. So I think that right here I would have 16%, and on the other side right here I would also have 16%. But the only part I want is this part I've shaded in blue, and that would be 16% according to the empirical rule. So that's a little bit interesting. I'm using the 6899.7 rule to find the answer to this question, yet the 68% that comes from the rule is not my answer. But I used that 68 to think about what was left over and then to split that in half and to ultimately answer my question. I also think this would be very difficult to do if I hadn't drawn a picture. So I would definitely recommend on all of these that you start off with a picture and that you do this numbering on both sides. using the standard deviation as your scale to mark off 3 notches to the right and to the left. Alright, let's go ahead and move on to part B and try another one of these. This time they want to know the percentage of the heart rates that are less than 85. So I'm going to start off in the same fashion that I did last time by drawing the picture. This time it'll go a little bit faster, but I'm going to number it in the same way. If I drop down from the peak, that should be the mean, and the mean of the curve is 70. And I'm going to go 1, 2, 3 notches to the right. It's the same numbering as last time, so this would be 85, 100, and 115. And on the other side, same thing, 1, 2, 3, and you should be roughly where the curve is disappearing, and that should be the 55, the 40, and the 25. And then I would want to think about the number they're asking about, which in this case is 85. So I'd draw a line at 85, and then I would shade what they want me to find, which would be everything to the left of 85. And then I would argue that the work I did above is mainly going to answer this question for me. If I drew another line at 55 right here, then I already know from the work up above that this area in the middle should be 68%. That's from the empirical rule, and that's the amount of data that's within 1 standard deviation of the mean going both to the left and the right. So that's this section right here. And then we also know from the picture up above the amount to the left of 55 is 16%, and the amount to the right of 85 is 16%. So in this case, I want the amount of area that's to the left of 85, and I've got that in 2 chunks here. There's 68% of it in the middle, and then another 16% off to the left. So I would say the answer to this question is the 68% in the middle plus the 16% that's over here on the left-hand side. That gives me the total amount that's to the left of 85. And adding that together, I have for Gary the 1 looks like 84%. So that should be the amount of area that's to the left of 85, or the percentage of heart rates that are to the left of 85. Just a quick mention, there's another way I could have done this and still got the same answer, and either one of these would be fine. Another approach to this would be to say the graph represents 100% of the heart rates, and if I look to the right of 85, I have 16%, and I want less than 85, so I don't want these. So I could say when I go to answer this, I want all the heart rates except for the 16% that are above 85, and that should just leave me with the ones that are less than 85. And if you do that subtraction, you get 84%. And again, same answer, so either approach would be fine. I think this is more direct because we're thinking exactly what they want, what's less than 85. But when you get to statistics, you'll find it's very useful if you have this flexibility to sometimes, instead of finding what you want and adding those together, to maybe sometimes subtract out what you don't want from 100% and get your answer that way. Alright, let's move on to another one. In part C, they want to know what percentage of the heart rates are greater than 100. So like I did on the other ones, I'm going to start off with a fresh picture and draw my bell-shaped curve. Dropping down from the peak, that should be the mean, so that would be 70. I'm going to go 1, 2, 3 notches to make it to the flattening out spot. Those numbers would be 85, 100, and 115. Again, just a reminder, our standard deviation was 15, so I'm just adding that 15 over and over again. And then 1, 2, 3 notches to the left would be 55, 40, and 25, and that just goes from subtracting 15 once, twice, 3 times. And then I'm going to mark the number that they're talking about, which is 100. So that's right here. And then how many standard deviations to the right is that? We could do a z-score, but we can also just count 1, 2. If I'm going to go 2 standard deviations to the right and I want to use the empirical rule, then I'm also going to go 1, 2 to the left. Because the empirical rule's 3 numbers, 68, 95, and 99.7, apply to going 1 standard deviation in each direction, 2 standard deviations in each direction, or 3 standard deviations in each direction. So once I see on the picture that I've gone 2 standard deviations to the right, I want to go 2 to the left as well. And then what I would know from the empirical rule, switch colors, is that in between these two, since that's 2 standard deviations out, I go ahead and bring the empirical rule back in for a second. if we go out 2 standard deviations in each direction, we should get 95% of the area. So the area in the middle right here should be 95%. And now just thinking about what that means in terms of their outside tails, I'm just going to do a little bit of math there. I know it's 100% overall for the picture. If I subtract 95, that's 5% left over. But where is that, on the left, the right? The answer is split among the two. So if I take that 5 and I cut it in half, that would be 2.5% on each side. So this is 2.5% and this is 2.5%. So I think I've got a decent picture at this point, but now what is it that I want from that picture? I want the areas that are, or the heart rates that are greater than 100, and that would be these to the right of 100 right here. And based on the 95% in the middle, we split it out and said 2.5% on each side. Well, that 2.5% right there are the ones that are greater than 100, and so that would be the answer to that question based on the empirical rule. Alright, let's look at one final one. This one actually turns out to be the easiest one, I think. Trying to do the area between 55 and 85 to estimate the percentage of heart rates in this category. So I'm going to start off drawing my bell-shaped curve. I'm going to drop down from the mean and from the peak and put the mean, which would be 70. I'm going to count 1, 2, 3 notches to flat. That'd be 85, 100, and 115. And 3 notches to flat on the left. 1, 2, 3 would be the 55, the 40, and the 25. And then I'm going to mark off the ones they want between 55 and 85. So 55 is here, 85 is there. And fortunately this time that's the same distance in each direction. So I said this was probably going to be the easiest one, because all we really have to think about is how far did we go in each direction. And we went 1 standard deviation to the right and 1 standard deviation to the left. So according to the 68, 95, 99.7 rule, since I've only gone out 1 standard deviation on each side, that should be about 68% of the data, or in this case 68% of the heart rates that fall into that category. Alright, so there's our first example on the empirical rule. This can be a little bit of a tough topic for you to digest, so you might even have to come back, watch this again to kind of see the thought process. And we also have another one on the next page. Alright, let's go ahead and look at another example. The scores on a psychology exam were normally distributed with a mean of 67 and a standard deviation of 8. About what percentage of scores were below 75? Alright, so because they said it's a normally distributed distribution for these, we're going to go ahead and draw a bell-shaped curve. Just below the peak, we'll drop down and put whatever the mean was, and the mean was 67, so that's going to go right there. And then we want to think about the idea that out to the flattening out spot on the curve is about 3 standard deviations. So we'll try and make 3 marks, 1, 2, 3, doing our best to roughly equally space those. Now on the other side, same thing, 1, 2, 3, with that third one landing right about the spot where the curve is about to disappear. And then we want to think of those as 1, 2, and 3 standard deviations to the right, and 1, 2, and 3 standard deviations to the left. The standard deviation is 8, so we're going to keep adding and subtracting 8 from the 67 as we go along those notches. So 67 plus 8 is 75. Add another 8, that would be 83. Add another 8, that would be 91. If you started at the 67 and subtracted 8, you would get 59. Subtract 8 more would be 51, and subtract 8 more, and we would have 43. So there's our numbering notched out using the standard deviation. And now we want to shade the area that they're talking about. So they want us to find what percentage of the scores are below 75. So 75 is right here. So I'm going to draw a line at that spot. And then when they say below 75, they mean less than or to the left of. So let's go ahead and shade the area to the left of 75. All right, and then whatever that area is, that's what the answer would be. We'll think of it maybe as a decimal and a percentage, but the percentage form would be the answer to this question. So we want to try and use the empirical rule to find that, and to use the empirical rule we need symmetry. So the 75 was 1 standard deviation to the right, so I'm going to draw another line in at 59, which would be 1 standard deviation to the left. And if I do that, then I know by the empirical rule that because I'm going out one standard deviation in each direction, the area in between would be this 68%. So this area right here would be 68%. That's not all the area in the blue, it's just this part right here. So we still need to add on this missing piece over here. So we're going to do a little bit of math on the side to think about what that would be. We know the total area under the curve is 100%. So let's subtract out that 68% in the middle, and that leaves 32% left over. Okay, but that 32% is all the area that's not here, so half of that's over here and half of it's on this side. So I'm going to take that 32% and cut that in half, and then there would be 16% left for each side. So this is, let's do this in a different color. So this part right here is 16%, and this piece right here is 16%. And now we've got all the parts of the graph kind of labeled with percentages, so we want to think about what we want. We want the part that I shaded in this teal color. That's this purple 16%, the left tail, and the 68% in the middle. So the area that we want is 68%, the middle part, plus the 16% on the left, for a total of 84%. So about what percentage of the scores were below 75? We would estimate that to be 84%, according to the empirical rule and what we're working out on this graph. Moving on to the next part, part B, about what percentage of the scores were between 51 and 83. All right, so I always want to really think about the graph when I answer these kind of questions and have a nice picture that I can mark up. And this picture is already very crowded, so I don't want to try and use the same one. So I'm just going to quickly duplicate that picture down here. Be a lot faster to do this time because we've already thought through the numbering. So do a decent bell shape, put that 67 in the middle. Think about 1, 2, 3 notches, 1, 2, 3 notches on both sides, and then go and label it just like we did above. So 75, 83, and 91, and on the other side the 59, the 51, and the 43. All right, so there we go. We have a fresh picture. Now let's think about their question. What percentage of the scores were between 51 and 83? Well, the 51 is right here, and the 83 is right there. And here's the key. How many notches to the right? 1, 2. How many notches to the left? 1, 2. So we can go ahead and shade the area that they wanted, which they said was between those numbers. And because we're 2 notches in both directions, that's 2 standard deviations in both directions, we've already got the symmetry we need to answer questions like this. So this is going to be a very fast one. We've gone out 2 standard deviations in each direction. We want to know the area in the middle. According to the empirical rule, if you go out 2 standard deviations on both sides, that's 95% in the middle. So this would be 95% right there, and that is the answer to our question. And just go ahead and circle that, and that's it. It's kind of crossed off there, so I'll write it one more time off to the side. But it should be about 95% of the scores that are between 51 and 83. All right, so let's move on to part C, about what percentage of the scores were between 51 and 75. So let's get a new picture going. We got our bell-shaped curve. We put the mean underneath the peak. 1, 2, 3 notches to the right edge. 1, 2, 3 notches to the left edge. Throw the numbering in there just like above. And then start thinking about the boundaries that they're asking about. So one of the boundaries is 51, so that's right here. The other one is 75, that's right here. So notice the lack of symmetry in that. We've gone 1 standard deviation to the right, but we've gone 2 to the left. So we're going to have to somehow create some symmetry if we want to use the empirical rule. So first of all, let's just go ahead and shade in the area. All right, and then let's create some symmetry by taking the 75, which is 1 standard deviation to the right, and let's go 1 standard deviation to the left and draw a line right there. So we already talked about that section between 59 and 75 in part A. That was 68%. So I'm just going to go ahead and label that again. We've gone out 1 standard deviation, so the empirical rule says 68% in this zone right here. So what we need to do now is add on this wedge right here. We know the whole left side is 16%, so this must be something a little bit smaller. But how do we figure out what that is? We need to use the empirical rule, so we need some symmetry. So we've got this boundary right here that is 2 standard deviations to the left. So creating the symmetry, let me draw in this boundary right here, which is 2 standard deviations to the right. And let me extend those up. And that's 2 standard deviations to the right and the left. We can see up here that's 95%. So from here to here is 95%. And somehow I want to use that fact and this fact to get at what is this wedge. So what I'm going to do here is I'm going to subtract. I'm going to take 95% and I'm going to subtract 68%. So what is that? I believe that would be 27%. So what is that 27%? Well, it's all this area from here to here with the middle subtracted out. So that means that 27 is the total of this wedge on the left and this wedge on the right. So this part right here and this part right there that's not shaded totals up to 27%. But we've got symmetry, so if we want to know how much each of those is, we can take that 27% and divide it into 2 equal parts, each of which would be 13.5%, and we can label those. So we don't need this little white wedge right here, but that's 13.5% according to taking the 27 that's here and cutting it in half. So this right here is also 13.5%. And we want the teal section, which is this 13.5% plus that 68%. So to get our overall answer, we're just going to add those two together. All right, so we have 68% in the middle, plus this left wedge right here is 13.5%. And we're going to add those together. So let's see, we get 81 right here, and then we have the 0.5. So 81.5% is the answer to the question for about what percentage of the scores are between 51 and 75. All right, so for a lot of people, these are tricky at first, so make sure you give yourself lots of practice. Make sure you always start with a fresh picture, and make sure you're always creating symmetry, and then think about creative ways to add or subtract, and maybe divide sometimes because of the symmetry to get the areas that you need. All right, that wraps up this section.